Okay everyone, so in this video what we're going to do is run both an independent samples t-test and a paired samples t-test. And just a kind of a quick note on the plots here, because I kind of brushed over it, is that all the plots will be there for both categorical variables we put in, so gender and condition, so those both are there. So you just have to navigate it to find gender depression, gender well-being, and again if I keep going back I'll get all the plots for both. Okay, where I just have to move left and right. Okay, so again I'm going to create a separate script for this, so just to contain the information on how to run the t-test and my analysis, and I'm going to link it to the setup. One thing I'm going to do just before I do that is that in the descriptives I did some data cleaning, and I would want, it's fine where it is here, but I'm going to actually put this back into the setup because I can consider that the setup of this is also doing some data cleaning. So all I'm going to do is, I'm not going to take it out of here, or I'm going to take it out of here, and I'm just going to put it into our setup and save it. And the reason is that whenever I want to run this script entirely, it would be nice if it also cleaned it as well. So then in this part I'm going to link this new script, and I'm going to call it O3 t-test. Again, the 3 is just an indication of the order, and I'm going to link to setup script. And all I have to do is just take this line of code, source O1 setup OR, and just do the same thing here. And in this case I'm just gonna type it again. I could also just copy and paste it. O1 setup.or, so that if I ever come back here and the environment is cleaned, so if I do this, I'm just gonna clean the environment and run it again. It will run these two, create these two data frames, and we can see it's done so with the cleaning I did last time. Okay, so that's the link. Now let's do our independent. Let's run an independent sample t-test. Okay, so for the formula for running independent sample t-test, what we can do is we type in t-test, and inside we can do, there's a formula which is your dependent variable by your independent variable, whatever group you're comparing. There's an argument in the t-test called paired, and if you're doing an independent sample you just set that to false, and then you can specify the data that you're working on, so our data frame. Okay, so in this case, just put this is syntax, and now I can run it. And what I'm going to do is I'm going to compare, let's say, males and females on well-being. So I can type in t-test well-being by gender. I don't want, it's an independent samples t-test, right? They're between groups, so I'm going to say false. And data being well-being df. If I run that now, we can see it runs our Welch 2 sample t-test. It gives us our t statistic, gives us our degrees of freedom, gives us our p-value. It also gives us our 95% confidence intervals and our means in group female and mean in group male. And later on, as you go on, there's ways to kind of clean this up and tidy it, but for now, for the sake of this, like when you're a beginner, the best thing to do would just be to copy and paste this information into, if you're writing a report or a journal article or whatever you're doing. Okay, so that's how to do an independent sample t-test. Now, what happened if I wanted, let's say, to do an independent sample t-test on the condition and compare, let's say, no caffeine versus low caffeine? Well, what I can do is just create another data frame where I filter out the high caffeine group, just for this example. So to do that, I'm just going to say, let's say, well-being no, let's say no low for no caffeine, low caffeine. Oh, right there. And to create this, I'm going to filter, and I'm going to use the well-being data frame, and I'm just going to filter out any rows where it equals high caffeine. Just get rid of any participant who was in the high caffeine condition. So I can type in condition exclamation mark equal, which means cases where condition doesn't equal high caffeine. So it'll only keep in rows where condition doesn't equal high caffeine. Press run, and now if I type in, just to check if that worked, I can do, let's say, table well-being no low time and extract condition. That's the $sign there. That just means select, take this data frame and select this column using the dollar notation. And what this does, it will print out the amount of participants in each group. And you see we don't have any in the high caffeine group. We have 140 in the low caffeine and 140 in the no caffeine. And then I can just take this, and I'm just doing it, so I'm just changing well-being into condition, and I'm just changing the data frame for well-being DF to well-being no low. And there, again, it produced a Welch 2-sample t-test. There's my main statistics. Here's my confidence interval, and the mean you can see in group in low caffeine versus no caffeine. So, so that's how you'd approach it if you had a categorical variable with more than 2 levels, but you just want to compare 2 levels. Okay, now we can do a paired sample t-test. And so let's say running a paired samples t-test. Now, neither 2 data frames I have here they're both between subjects, or well, the PsychoDF one is repeated measures, but it's not in the right structure. But we've actually run before a paired sample t-test. We did it in the first class on the sleep data frame. So if I type in sleep here, it's already loaded into OR, so we don't have to create anything for it. And so we can run a paired samples again on this. And to do that, the syntax is the same. All we just have to do is change paired from false to true. So let's do that now. Let's just say this is the syntax. And I'm going to take this here and run a t-test on it. So t-test, our dependent variable is extra, that was the extra hours of sleep. And our independent variable is group. Paired equal to true, data equal to sleep. If I run that, what we get is a paired t-test. We get our main statistics up here, t, degrees of freedom, p-value. We get our 95% confidence intervals, and we get the mean difference. Again, in this is the case of you wanted to export these results. Later on, you'll find, if you keep going along, you'll find ways that require a bit more programming about how you can just automatically extract them. But for now, what I would just be doing is just copying and paste them into whatever report you're writing. But that's how you run a paired sample t-test. So that's really it. Like in case of, if you're ever doing independent and paired samples, you're just copying, take the syntax and you're just throwing in your relevant dependent variable and independent variable for both the independent and paired sample t-test. Okay, so in the next video what we're going to look at is we're going to do a between subjects ANOVA.